Welcome back for another deep dive. This time, we're going to be looking at earthquakes.
Oh, yeah.
Yeah. So
Those are always exciting.
they are exciting and kind of terrifying too, right?
Yeah.
And you've sent over some really cool geology presentations for us to dig into.
Oh, good. I'm glad you like them.
Yeah, and it looks like it's going to be a really fascinating deep dive because we're going to be looking at not just like what causes earthquakes, but the effects that they have and then sort of what they mean for us.
Yeah, I mean, it's so much more than just rocks and tremors.
Well,
It's really about, a force of nature that shaped the planet we live on.
exactly.
And understanding it can help us, kind of prepare for the future.
Absolutely. So let's get started with just the basics. When we say earthquake, what are we really talking about?
Well, at its core, an earthquake is a sudden, violent shaking of the ground.
Okay.
But this shaking isn't random. It's caused by movements deep within the Earth's crust, specifically along what we call tectonic plates.
hmm
And these plates are like giant puzzle pieces that make up the Earth's outer layer, and they're constantly shifting and grinding against each other.
Okay, so I'm picturing this like massive jigsaw puzzle beneath our feet.
Yeah.
But what makes these tectonic plates move in the first place? It's not like they just decide to slide around for fun.
No, it's all driven by these incredible forces deep within the Earth. Like imagine a pot of boiling water.
Okay.
The heat at the bottom causes the water to rise, then it cools and sinks back down, creating this like circular motion that we call convection.
So is there like a giant boiling pot under the Earth's crust or something?
In a way, yes.
Yeah.
Deep inside the Earth, there's this layer called the mantle. And
Okay.
it's super hot, incredibly hot, and this heat creates these massive convection currents similar to that boiling water.
Okay.
And these currents drag the tectonic plates along with them, causing them to move and collide and interact in these really, interesting ways.
So that's kind of a wild image.
Hmm.
So how does this slow churning motion, like deep down, translate into these like sudden violent earthquakes that we experience?
It all comes down to what we call fault lines.
Okay.
These are the zones where the tectonic plates meet.
hmm
And because the plates are always moving, it creates this immense stress along these lines. Imagine you're bending a twig. You can only bend it so far before it snaps.
Right.
And the rocks along a fault line are kind of the same way. They can only withstand so much pressure before they reach their breaking point. When that happens, they suddenly fracture and slip, releasing all that pent-up energy in the form of powerful seismic waves.
Hmm.
These waves radiate outward from the point of rupture, causing the ground to shake sometimes violently, and that's the essence of what we call the elastic rebound theory.
So the elastic rebound theory is basically that buildup of pressure and then it releases
Yeah.
and causes that shaking. But we've been talking about fault lines generally,
Hmm.
and I know that there are different types of faults, right?
Yeah.
And they each move in a different way, creating different kinds of earthquakes.
You're absolutely right, and understanding these different fault types is key to understanding the whole spectrum of earthquake behavior.
Okay, so let's break it down. What are the main categories of faults that we're looking at here?
Okay, so let's start with normal faults. Imagine you're holding a cracker horizontally, and you pull both ends apart.
Okay.
Eventually, the cracker breaks, right?
Yeah.
And one side drops lower than the other.
Mm-hmm.
That's essentially what happens with normal faults. They're formed by tension, that pulling apart of the Earth's crust.
Okay.
So think of rift valleys like the East African Rift Valley,
mm-hmm.
which are formed as the crust stretches and thins.
So normal faults are about things pulling apart.
Right.
What about reverse faults? How do those work?
With reverse faults, we see the opposite force at work: compression.
Okay.
So instead of pulling the cracker apart, imagine pushing those two halves together.
Mm-hmm.
One side would be forced upwards over the other.
Okay.
And this is actually how mountains are formed. The incredible force of colliding tectonic plates pushes rock upwards, creating these massive mountain ranges,
Wow.
like the Himalayas.
It's amazing to think about like these forces that shape the world around us.
Yeah, it's incredible.
So we've got normal faults pulling apart, reverse faults pushing together. What about strike slip faults? Those seem a little trickier.
Yeah, strike slip faults are like two blocks sliding past each other horizontally.
Okay.
So picture two bricks on a table. You push them past each other in opposite directions. They'll grind along their sides.
Okay.
That's similar to what happens at a strike slip fault.
Gotcha.
The most famous example is the San Andreas Fault in California,
Right.
where the Pacific Plate is grinding past the North American Plate.
Go on.
And this constant grinding is what makes California so prone to earthquakes.
So we've got normal faults pulling apart, reverse faults pushing together, strike slip faults sliding past each other. It's like a giant geological dance.
It really is.
But this is all happening underground. So what does it mean for us up here on the surface?
Well, this interplay of tectonic forces is what shapes our planet,
Yeah.
creates mountains, valleys, ocean basins.
Right.
But it also has a huge impact on our lives because it's the source of those earth-shaking earthquakes that we've been talking about.
Okay, so let's get into the real-world consequences of all this underground activity.
Yeah.
We've talked about, like, the destruction that earthquakes can cause,
hmm
but I'm curious to dig into the specific ways they impact our lives and the world around us.
Yeah. So the most obvious effect, of course, is ground shaking.
Right.
That's what we feel during an earthquake, those vibrations radiating outwards from the rupture point. It's the direct result of those seismic waves we were talking about earlier.
And I imagine that shaking can vary a lot, right?
hmm
Like a small tremor versus a major earthquake.
Oh, absolutely. It's like comparing a rocking to a violent jolt.
Yeah.
The intensity of the shaking depends on several factors: the magnitude of the earthquake, the distance from the epicenter, the type of ground beneath our feet. But ground shaking itself is just the beginning. It can trigger a whole chain reaction of other events, each with their own consequences.
So what are some of those other effects that we need to be aware of
Mm.
besides the shaking?
Well, one of the most dramatic is surface rupture.
Okay.
Imagine the ground literally splitting open during an earthquake.
Yeah, I've seen pictures. It's crazy.
Yeah, these ruptures can extend for miles, damaging buildings, roads, anything in their path.
It's like the earth is cracking open.
It's a powerful reminder of the forces beneath our feet.
Yeah.
And then there are landslides,
Oh, right.
which can be equally devastating.
Mm.
Earthquakes can destabilize slopes, causing tons of rock and soil to suddenly give way.
Yeah.
Areas with steep slopes and heavy rainfall are especially vulnerable to this.
I've seen videos of landslides triggered by earthquakes, and it's just unbelievable, like whole mountainsides collapsing.
It's incredible and terrifying.
Yeah, and then there's tsunamis too, right?
Oh, yeah, we can't forget about those.
These giant waves that can travel across oceans.
And cause all this flooding.
Yeah.
Tsunamis are a stark reminder that the impact of an earthquake can extend way beyond the immediate area.
Yeah.
They're generated by underwater disturbances, most often earthquakes, and they can travel thousands of miles across open ocean, striking distant coastlines with incredible force.
Wow.
And it's not just the size of these waves, it's the surprise factor. They can arrive with little warning, giving coastal communities no time to prepare.
So it's like this shock wave going through the ocean.
Yeah, exactly.
With these far-reaching consequences.
Right.
And speaking of unexpected consequences, I was reading about something called liquefaction, and it sounds kind of crazy.
Liquefaction.
Yeah. Is that like...
It does sound a bit like science fiction, but it's a
Yeah.
very real and very dangerous phenomenon.
Okay.
It happens when water-saturated soil, which normally feels solid beneath our feet,
Mm-hmm.
loses its strength and stiffness during an earthquake.
So it's like the ground just turns to liquid.
It's like the ground suddenly turns to quicksand.
Wow.
Buildings can tilt, sink, or even completely collapse as the ground beneath them loses its ability to support their weight.
It's like the earth opening up beneath you.
Yeah, it's a recipe for widespread damage and disruption.
So it seems like earthquakes can cause so much damage in so many different ways.
They really can.
From the ground shaking to landslides, tsunamis, liquefaction, it's like this cascade of consequences.
It's a powerful reminder that earthquakes are not isolated events. They trigger this chain reaction of hazards, and understanding those interconnected effects is crucial for predicting the potential impacts and for preparing for them.
So I've talked about ground shaking, surface ruptures, landslides, tsunamis, and even liquefaction. But there's one more danger associated with earthquakes that we haven't mentioned yet. Fire.
Yes, fire. Often overlooked, but incredibly destructive.
Right.
Earthquakes can rupture gas lines and electrical wires, sparking fires that can quickly spread and add to the chaos.
Yeah.
Imagine trying to fight a fire while the ground's shaking and buildings are collapsing.
That's a terrifying thought.
It's a nightmare scenario.
So earthquakes can cause damage in so many ways, from the shaking to these like secondary effects that ripple outward and cause all this destruction.
It's true.
Kind of paints a grim picture. But is there any way to predict these events, or at least prepare for them in a way that mitigates the risks?
That's the million-dollar question, isn't it?
Yeah.
And while we can't predict earthquakes with perfect accuracy, we're not completely in the dark either. There are clues we can look for, patterns we can study, and one of the most intriguing areas of research focuses on what we call seismic gaps.
Seismic gaps. What are those?
So imagine a fault line, like a zipper. Over time, sections of that zipper unzip, releasing stress in the form of earthquakes.
Okay.
Seismic gaps are those sections that haven't unzipped recently, those quiet zones where stress is building up but hasn't been released.
So it's like the calm before the storm.
That's the thinking. It's as if the fault is catching up, trying to release all that pent-up energy. By identifying and monitoring these seismic gaps, scientists hope to gain a better understanding of where future earthquakes are likely to occur. It's not about predicting the exact time and date, but rather identifying areas of higher risk.
So it gives the general idea of where to expect them, but
Hmm.
we can't say exactly when.
Right.
It sounds like earthquake prediction is still more art than science.
Pretty much.
Yeah.
Yeah, it's really hard to pinpoint the exact when, but these seismic gaps at least help us focus on the where.
So we can't prevent earthquakes, but we can at least try to be more prepared.
Right.
So what does that preparation actually look like?
Well, it's a lot of things. Building codes in earthquake-prone areas are designed to make structures more resistant to shaking.
Right.
Emergency response plans are developed and practiced,
Mm-hmm.
and early warning systems are being implemented in some regions,
Oh, cool.
which can give people a few precious seconds to take cover.
Oh, wow. So it's like giving people a little bit of a heads up.
Yeah, a little bit of time can make a big difference.
Wow. So it's about designing buildings to withstand the shaking and having these plans in place.
Exactly. And it goes beyond just the immediate response, too. It's also about long-term planning, investing in infrastructure that can better withstand earthquakes, and just raising awareness so people can make informed decisions about their own safety.
So it's not just about surviving the earthquake itself. It's about being prepared for the aftermath
Right.
and understanding that there are these other risks like landslides and tsunamis.
Exactly. It's all connected.
It sounds like understanding earthquakes is about so much more than just the science.
It really is. It's about using that knowledge to create safer communities.
Right, and to build a more resilient future.
Absolutely.
So knowing what we know now about the seismic gaps
Yeah.
and, the potential for future earthquakes, how should we prioritize earthquake preparedness and these infrastructure investments?
That's the big question, isn't it? It's a complex issue, especially when resources are limited.
It's like weighing the risks against the costs. But even if we don't live in an area that's right on a fault line, why should we care about earthquakes? How do they affect us more broadly?
Well, earthquakes can have these far-reaching consequences. Think about supply chains, for instance. A major earthquake can disrupt transportation networks and cause these huge economic disruptions.
Right, it can affect the whole system.
And then there's the global impact of a tsunami triggered by an earthquake thousands of miles away.
So even events that seem really far away can have these ripple effects.
Exactly. We live in a very interconnected world.
So it's a reminder that we're all connected. And these things matter, even if they don't seem to directly impact us.
Exactly.
So in this deep dive, we've explored the science behind earthquakes, the different types of faults, the effects they can trigger, and the challenges of prediction and preparedness.
It's been quite a journey.
It really has. So what are some key takeaways you hope our listeners will walk away with?
Well, I hope they gain a deeper understanding of the forces that shape our planet. Earthquakes are a natural part of Earth's processes. We can't stop them, but we can understand them better.
And hopefully live with them more safely.
Exactly. And I also hope they understand that earthquake preparedness isn't just about surviving the shaking.
Right.
It's about being aware of the potential for those other effects and taking steps to mitigate the risks.
So being prepared for the whole package,
Right. Landslides, tsunamis, liquefaction fires.
it's about being aware and being proactive.
Absolutely. And finally, I just hope listeners are inspired to learn more. There's still so much we don't know about earthquakes, and research is always pushing forward, leading to new innovations.
That's so true. This has been a really fascinating deep dive into the world beneath our feet.
It has been fun.
It really has.
Mm.
Thank you so much for joining us. And until next time, keep exploring the world around you.